Now we are discussed with this Miller indices. So before we are Miller indices, we have discussed with this Miller indices. So Miller indices were introduced in 1839 by the British mineralogist Williams Halves Miller. The method was also historically known as the Millerian systems and the indices as a Millerian. The orientation of the surface or a crystal plane may be defined by the considering how the plane or indicated by any parallel plane so intersects the main crystallography axis of the solid. The application of the set of the rules leads to the assignment of the Miller indices. H. Kegel, this is a rules leads to assignment of the Miller indices. The set of number which actually which is this intercept and the may be used in uniquely identify the plane or surface. To determine the crystallography plans, we take the unit cells which 3-axis coordinate system. Unit cell smallest repetitive volume that contains the complete lattice pattern of the crystal. The 7 crystal system and 14 crystal lattice. See that this pictures A, B, C and then X direction, Y direction and Z directions. The lattice constant is A, B and C. The lattice constant. The unit cells types. A unit cell is the smallest component of the crystal that reproduces the whole crystal when stacked together. So see that this pictures primitive is simple cubic body center, see center of this atoms and phase centers. Each and every phases of this atom of this phase center. So center of the atom in the every phases and end center. So see that this the opposite this corner of this end center. See that this and the crystal 7 crystal systems combining this cubic, tetrahedral and orthorhombic hexagonal, this monoclinic and triclinic. So this is a crystal and shape and crystal structures. So primitive P is a primitive. The unit cell contain only the single lattice point and a internal. I is the internal. P is a primitive. I is the internal. Unit cells contain an atom in a body center. Body center is another one. F is a phase. The unit cell contains atom in all phases of the plants composing these plants. The planes over this area. That C is the center of the unit cells contain the atoms, center of the sides of the unit cells. This is all the and 4 types of this primitive body center and phase center and end center. The unit cell is the smallest component of the crystals that reproduce the whole crystals when stacked together. See the lattice parameter in cubic, orthorhombic and hexagonal crystal systems. The rules of the Miller indices determine the intercepts A, B, C phase along with the crystallographic axis in terms of the unit cell dimension. Take the reciprocals, clear fractions, reduce to the lowest terms. If the plane has a negative intercept, positive intercept, the negative numbers is denoted by the bar is above the number. This one. And never alter negative numbers. For example, do not divide and minus 1 minus 1. This each plane is if plane is parallel to axis, intercept is 0 and meet at infinity. See the cubic and orthorhombic and hexagonal the directional of this A, B, C and alpha, beta and gamma. The basic definition of the lattice sites. They define the basic terms and give examples of points, atomic positions. This is a atomic position of this point vector. Define the particular directions, plane normal and Miller indices. Define the particular plane. So relaxation to diffraction. 3 indices for this cubes and 4 indices of this HCP. See that the orientation of these planes or phase in a crystal can be described in the term of their intercept on the 3 axis. The Miller introduced a system to design a plane of the crystal. He introduced a set of three numbers of specific plane in a crystal. This is a set of three numbers known as the Miller indices of the concerned plane. The Miller indices is 0. The plan is a parallel to the at that axis. See the x direction and y direction is the directions. Origin is 0 is the origin, and another note new origin. So this another one is another dimensional and negative bar and the directions. See that's a two different origin and then note new origin. So different angle, different plans. The see that this 100 is a origin, another is origin is a 1 bar is 0. So this is a plan is a crystal is 100 and another is a bar 1 is a 0. A Miller index is a smaller Miller the index the more nearly parallel to the plane is to the axis. Another one is here the larger of a Miller indices that more nearly perpendicular to a plane is that is axis. This is here one of these multiplying dividing Miller indices by the constant has no effect of the orientation of the plane. Crystallographic planes. If the plane passes through the origin, either construct another plane, another one is here, another one here, create a new origin. So one is another plane is or new origin. Then each axis decide whether the plane intercepts or parallel to the axis. Algorithm of the Miller indices read of intercepts of plane with axis in term of A, B, C. Take reciprocal of intercepts. Reduce the smallest integer value enclosed the parenthesis of no commas. The crystallographic planes are specified by three Miller indices H, K, and L. All parallel planes have the smaller same Miller indices. We need a way to identify direction and the plane of atoms. The deformation unit under the loading slip occur the certain crystalline planes and in a certain crystallographic direction. Before we can predict how materials fail, we need to know that what modes of failure are more likely to occur. So why we need to direction and plans. See this and 1 0 0 0. See that this the plane of refer to this origin at the point of 0. This will be short. This direction, three-dimensional directions of the axis 2 and the x direction, y direction, and z direction of the plane of the axis of the intercepts to 0 0 1 of this plane of the refer to this origin point. Another one is another one is another equivalent plane is the same directions 0 0 1 planes. See that this another one is other equivalent points 1 1 0 is planes. The different angles and different dimensions, and 0 is the origin point, and x y z is a directional and intercepts of these faces of this and corner atoms. This is a plane of this 1 1 0. Another one is a triple 1 face and each atom 6 and the end of the corner of the atoms 0 and x y direction and z direction. Each atom's corner is a 1 corner of this atoms and 1 is a plane refer to the origin at the point of 0. This is a starting point is a 0 and the angles of the each point is corner of the atom is edges of 1 and 1 and is 1 1. And Miller indices are a symbolic vector representation for the orientation of the atomic plane in a crystal lattice are defined as the reciprocal of the fractional intercepts which the planes makes with the crystallographic axis. This is mainly important to the reciprocal of the fractional intercepts 1 by 2. This is a fractional intercepts. One is the main only part of this, and the part of the section is the 1 by 2 fractional intercepts. And to find the Miller indices of the plane, take the following steps. Determine the intercepts. The plane of along the each the three crystallographic directions. So already we have to see this different direction x y z directions. Take the reciprocal of the intercepts, the point of the intercepts. The fraction of result multiplying each of the denominator of the smallest fractions. So this is one of the Miller indices, reciprocal of the fraction intercepts. Family of the plane. Oh, 1 on 0. See that this the structure of the crystal structure in xy direction, intercepts of these atoms, and the angles is 1 on 0, 1 bar 0, negatives values of 1 bar under different, and then direction it will be changed on this the cubic structures on this intercept. And see that this different planes, see, and this one the angle will be totally changed of the interface, the intersection of the plane. See that this, and another one, another 101 1 bar 01 slightly to change it to another faces to the corner of the atoms. 1 bar 01 101 bar 011, another direction is totally slightly changes of this. See the direction it will be totally changed on this two different both of the picture. See this all the each note it down, and see the direction of this plane is xy z direction, and the negative values of this bar 1 bar 0 is here. The direction it will be changed to another values. The plane will be changes. For the face center cube, this is a unit cell with a 1 1 0 plane. So see this A B C D E F, this is each corner of the atom, intercepts of this the center of the body of the face structure in each corner. So see this center of the face. And another one is a BC, body center cubics, unit cell which is 1 1 0. The BC is a body center cubic unit cell which is a plane of 1 1 0 plane. See that this cubic structures each corner of the atom in A B C D. You can check it now. In center of the point is a C, is a body center. This is body center of the atom. This plane axis of this 1 1 0. See the examples, and x direction, y direction, and z direction. See this, the first phase 1 0 0 is the axis, x intercept of the point, x direction, y direction, and z direction. This is a intercept point is here, starting point is here, and one another one is here, y is the direction. You see infinity, infinite means this here not end of the continuity, and y is a infinity. Reciprocal and is 1 by 1 is equal to 1. Ratio is a smallest ratio. 1 into infinity 0. 1 into infinity is a 0, smallest ratio of the Miller indices to given to the value of this